Hi everyone. Today we're gonna explore the OBI AI system or the Ontological Bayesian AI system, which stands for the hot system AI system called OBI AI. It's gonna or the hot system, which means hot in Igbo. The Ontological Bayesian AI system. OBI. Today we're gonna look at the hypothesis for the project, which is complete anyway, and to see whether it's solved or not. You know, we're gonna see how the hypotheses have been addressed systematically, and why use OBI AI and the infrastructure as a service for through obnexus.org. You get to understand that the infrastructure is gonna use is a polygon system, continue something called OBI core, and we're gonna come back to the ontological Bayesian infrastructure function core system, which is OBI core system. Uh, that allows you to orchestrate components for AI systems with a large language model core written in Rust for processing large programmable features. So let's begin and see how we trace them side by side. 1 second, I'll just pause my screen. Okay, now we're gonna go through the system now. We're gonna go through the proof, like the hypothesis I made, I developed. We got the first hypothesis, which was started as we got hypothesis 1.1, solutional versus unbiased AI model. First of all, OBIAI is ontological Bayesian infrastructure for AI or AI systems that are unbiased. The Bayesian is just using Bayesian inference to reason, to make sure that AI reasons correctly. The problem that this model addresses is, is using something called top-down reasoning and bottom-up reason to dictate how data resolve demographically. The thing is, take example, an AI cancer detection system that detects AI, detects AI that records that records cancer in people. Say you have a doctor who detects cancer in patients, and this guy is let's say a like me, a black is in the UK, but I smoke a lot, which is not true. But let's say example, I start smoking, I do it a lot. The AI system, will able to detect my cancer, because the system is biased, traditionally biased. Because it's demographic, it's localized. It doesn't generalize. It generalizes based on I am. You can't detect me because I am an outlier. It says I am demographically abound. So if I was in Nigeria right now, or Biafra, or anywhere close to Nigeria, and I'm black, and a white and a Caucasian enters the Nigeria and gets cancer, smokes a lot, drinks a lot, he or she will then be intoxicated, but still be the outlier that is the no AI. What the data set what OBI AI is much achieve is being unbiased in data modeling, using and because we have a model of abnormality and normality. Because normal is like, when something is normal, it's just normal. Like normal means it's just accepted. It's perceived as normal, but the online cause is meant to be addressed. This model you see on the screen is called see the model you see on the screen. Uh, See this here. This model here, the black box model. It's really, oh, it's my pen. Yes. So this is emphasizing the black box model. Or or the black box. See this is a see this is the black box. The black box here. It's meant to address that kind of problem. Yep. This is a yep. That's the black box translator. So when the input goes against it, the black box model we can't see, we can't observe, and because the black box is inherently biased, it's just like bias. It's biased, so you can't really understand what's going on and how the model transforms bias input to bias output. Hence, all AI too. So this how the system works. A good thing about this, you can't really control this bias parameter. You can't control it. It's hard to control it. Now, how OBI AI addresses this problem? Something with a co-founder. The co-founder is just how the system processes information based on the input speed. It's just thinking about bias tuning. Think it as bias system, adjusting weights of the bias parameter to get so the confounded data set and there's bias parameters here. The input is bias. We have the bias parameters you have to address. Now, the bias parameters are just the inputs that are to mitigate the bias. How you want the options to the AI to address nuance in context. How do you want the AI to actually work? The parameters and the inputs, like the how much is it? And you get the bias apple using top down and bottom up reasoning. Now, I'm gonna give you an example of when this bias parameter will apply, based on the confounder. The confounder is really a big issue. As a result, there's a case study that came up in Nigeria. People in Nigeria are happier than people in the UK. This is a well treated such on the internet because that's what COVID is. Why do we have a health and social care system in the UK and people are not happy? People are miserable or like more happier, less because it was ranked as Nigeria is ranked as the second happiest country. Was it next to Nigeria? I believe the UK is ranked 11th based on the hierarchy. I was saw last 20. My understanding is using a subjective reason model is that in Nigeria we get support from the community itself, well not the government support. We get localized community support by our friends, by our family, but not directly from the government. You know, we do get not because we do get some from the government, but we just get directions. We don't get the full support in place. But to address our problems, what is a housing problem, what is a shelter problem, what is a food supply problem, the neighbors mingle to solve each other, and everyone is satisfied and therefore happy. This is the nature of the UK. UK doesn't have that kind of social health system, social, health, social, and housing system for young people or children, and they end up trying to go to the government for everything. Now, the government has to do for them, can't do for them, based on can't do for don't actually address their needs, and they're being directed everywhere there. The co-founder, or let's go to confounder hypothesis, is really about how that bottom-up system works, for how people are happy, how an outcome is achieved. Is there some case that there's some cultural case or some ambiguity, some edge case, some corner case the system has to address based on the base case as a foundation? What's the of is there a nuance in understanding subjectively, objectively, just observing the world to address something, to de-bias the expert, because the EBA is still putting input on the biased person. Uh, wait, do I have to say? So we got two models. We got top-down reasoning and bottom-up reasoning. So top-down reasoning is the idea that you start from a single source of truth, and then reason your way downwards to using a statement or claim. Uh, uh, let's say, example, all swans are white. Okay, let's say it's just so the same thing. So there's the different models of reasoning. I've never seen a black swan, therefore all swans are white. So that's a truth. You can admit it. It's a hypothetical. It's a hypothetical truth. It's like it does work in context, and can use subjective reasoning. That's objective reasoning, called top down reasoning, because everyone has not seen a black swan. Or the infamous Hercules is a man. Therefore, I can't remember that. Yes, that's top down reasoning. Therefore, and we got which can be modeled as a Bayesian inferential model, based on the input data set or the amount of man you see or the amount of swans you see. That's a white or black. So that's the confounder hypothesis, and we got the subjective one, uh, since or uh, I've never encountered a white black swan. All swans are white, or is it like and that's like the reason of the bottom up. It doesn't have subjective or objective, but that's the easier way to relate to it. It's meant to be using reasoning systems. How the base case for that reasoning, or the bottom up analogy, how the system, what's the foundation to that system, what's the bottom up way top-down system to reason that output to devise that data. Now, we have qualitative data and quantitative data. Qualitative refers to the quality, the data set, like cats, dogs, which are data regarding animals, wallets, colors, things you can quantify based on their properties, what you observe, quantitative data. Uh, um, what I'm really getting at here is top-down reasoning and bottom reasoning are what's used to address the a bias and unbiased output, in a unified source cluster, unified approach to the biased output, because you can get a data set, you can still get the biased output, and this remains the represents the bias. Yep. So we got the hypothesis two. AI is pattern learning. So when you train an AI system, when you train an AI system, you are really training as pattern recognizer. You're really training it as a kind of pattern recognizer. It's becoming a pattern, and that pattern is being amplified. You go in here, it becomes pattern, and then you get a bias prediction, and you get a bias output. That's what it's saying. So you see, there's a step. So it then goes back into the feedback loop. So this goes here. You're using AI's biases, pattern matches. That's not what you want. You want to not make sure they understand how to reason, not just match to resolve context of problems. So that's what it is. That's a hypothesis that says why AI can crash because it's looking for patterns in data or singular. So if you have an AI car, it's looking for patterns in its own data set to address that problem. I will never let the AI car drive me if it just works on pattern matching. Because it can match a wrong pattern or what is known as a false negative, a false positive. So we have a standard structure. We got the OBNXS legal. So we got true positive. The AI matches correctly. True positive is true, and the AI coordinator is true. False positive. The AI coordinator is false, which is the matrix. We got true negative. False negative, which means the AI falsely identify is negative, negatively identified as falsely, and false positive. So the AI catches that it's an error. So you got true negative, true positive. Yes, true means the AI fails to, and these are all problems for each question, each problem you address in the sound case. This is called a QA matrix. QA matrix stands for quality assurance. It's a pattern of sounds that have this AI system. Is this sound? Does it not match patterns? Is it meant to address the four cases: true positive, true negative, false positive, and that is what I'm saying. If you go to github.com/obnxslegal, you can read about the QA matrix or the quality assurance. When people say quality assurance testing, they're talking about test-driven development of quality of code, not just quantity of the code you write. Because you're not trusting all the case indefinitely of the test. You're testing the quality of that code that you wrote based on what you developed. Not just writing test, which is called a QA test, which is TDD or test-driven development lifecycle pattern. It's not a BDD, although it can apply to BDD because BDD testing is a behavior-driven development. If you apply BDD, the best way to just use it is just test without tested BDD is use TDD or test to develop artifacts with integration test, unit tests respectively. You don't have to do system testing, but that's what that means. QA matrix. So that's the pattern layer about it. So this is a bias pattern matching input data. This is just an example. So you got the input. These the bias models. You see, that's what it means. This is computationally done. So you got the epoch for training. Do epoch for each sample of data set given an element D. Do you compute with? This is just biasing how this works. You don't want this in your code. It's just the bias representation of the pattern matching algorithm. So we go hypothesis 3. Now it's hypothesis 3.1 and 2.3. Hypothesis 3.1 states 3.1. Yes, Hyper 3.1 is just a concept of unboxing. The two type of unboxing. Unboxing refers to the concept of gathering the data, how the AI processes the inputs. Unboxing refers to unboxing data or sorting out data to gain like a map of understanding. You know, what is a 2D map or 3D map of that information set? You know, where does this fit into the cluster of information? How do I categorize this thing I already know? If it's talking about cooking, he's talking about cleaning? You know, because you know that's what the news is meant to understand. So how this works, it's meant to work. So we have the concept of 4D tensor. If you're familiar with the machine learning models, 4D tensors represent an inner monologue. You know, our brain, our processing of 4D. In our brain, that's how it works. It's this kind of 4D relationship to work. The 4D tensor is the model of the system. So, how dimensional reduction works? It's very important to understand this. How dimensional reduction works is you take say you are making a 3D game. 3D game. If you're using a dimensional reduction, you have to reduce that state. So you got the 4D tensor. The 4D tensor is just a parameter here. So if you define D, let's call it D for dimensional dr. Dr n. Oh, sorry. Dr. I can't remember. Dr n. Dr. N, which is the sorry. I can't do this. Wait. Okay. DRD equals DRD the equals n minus one equals d okay, you know what, I'm just gonna try to do some formalization here. So what I'm saying to you is we got to understand that this the whatever structure, whatever your model using, when you have a something called the magnitude. So this is the formula. I want you to remember, uh, B R D equals so dr refers to the dimension. It's just a function of showing dimension equals d minus one. The that's what you're trying to do. This is just the magnitude, like the magnitude of that dimension minus one. You got to remove a dimension, which is just what it's saying. So the dr refers to the dimension reduction of the system minus one. This is a very good practice to do. You want your AI system to able to create a 3D map of that information. Whether it's a 3D game, you give it a 3D. If it's a 3D game, and you want it to process in real time, you use a 4D tensor to model that and then transform that data using dimensional reduction or unboxing. Unboxing is a concept of the system of unboxing, structural unboxing and unstructured unboxing. Structural unboxing refers to the structure of that. So what you're doing, what you want to instantly to understand formally or something. The structure of the data is meant to be structured. What is input is unstructured. Say it just goes to the internet session, you have to structure the data in a way that it can be processed further. This microcreative process it can be processed. It's like a brainstorming using k-n clustering. K-n clustering refers to it's an algorithm from graph theory to cluster information into categories, not by ij, by k. K refers and k degree just means reduce that to the a b 2d 3d 4d system. K-n clustering is a graph theory method where you cluster information based on category. It's not using the nearest nearest neighbors, just to categorize data based on what they are meant to achieve for the information set in the neuron of the brain. so it can be processing information coherently, not just matching patterns. It can index weather information based on the category you've created too. So the k clustering is really about reducing to the k dimension, ijk, where ki represents the I-axis, the x-axis, the y-axis, the z-axis, or the map, and then the k represents the 3D map. K3 plus 3 map, 3D. So if you have 4D tensor and you have a AI system in a game or in the real world, you have to understand the 3D map is just it's all what it's interpreting directly, what is noticing, in that game, what is tracking in a game, and that gives it, and that can be semantic. What you can now, can find out how what you can now the AI have a semantic understanding. I now got unstructured unboxing. Say you have like the same data coming from the internet, and you now using it for creating. You can this allows to AI to create new solutions to problems. Using something called dimensional game theory, which is dimensional game theory refers to the concept of using dimensions, offense, defense, attack, to strategically address problems, not just linear bound matching or. It's meant to it's dimensional game theory is about the real world continuous spaces actively using to solve semantic filter or flash understand systems like that. That's dimension. It's in dimension. So every strategy you have is in dimension. So take multiple chess for example. Chess refers to the standard model of the chess. If someone plays, say you have two players in chess. I'm trying to give you the dimensional game theory concept. Two players and they play a perfect game. There'll be no victor. There'll be no determinism victor. The game will end in a draw. That's determinism. So it's determinism style. There'll be no winner because they played perfectly. Dimensional game theory, it says if there's an offense, defense, and attack a strategy, and one person deploys a strategy like a flank, and get the opponent to give in some pieces of this, just one piece. They have an anchor to win that game. They can win that game because they went ahead to not play a perfect game or do the most optimal move. But if they can do it too, but using strategy to address that problem. Hence the dimensional game theory. So I'm going to see my AI system play chess too, maybe on chess.org. But that's how dimensional game theory reacts. It's about creating these things called dimensions and addressing problems for that strategy you're trying to deploy. Whether it's an AI strategy or like a strategy that affects user. So this rule, you have to remember the DRD equals D minus 1. So that's how the dimension goes. So every time you have if you're using a 5-dimensional tensor, use it to a 4-dimensional tensor, and so forth and so on to get the output. You map a clear output to the input to the output, which is the 3D for the 4D, a dimensionless. You can apply a dimension recursively on the other step, on this side, on this step here. You can apply it indefinitely, but the goal is a semantic understanding and semantic reasoning. So this is the algorithm, structural unboxing. Yes, this algorithm is you're going to import but there's unstructured unboxing, which is the unstructured. If you're working with the unstructured data, you want the AI to process that data, just on the internet, use of formats, or you want some structured data. Structural just refers to data structure. Structured data. If you're working with tables or rows or like data, hierarchical data, you can use structural unboxing to get inside the data. We got the hypothesis 3, modular system architecture. So this is the hypothesis. This is OBI core, the Ontological Bayesian core system infrastructure for function core system. Modular. So we got, you see this. We got voice interface. So we got the base LLM core. This base LLM code is to be written in Rust, Rust.exe, which is a programming language. So this is the LLM. You can now have the FFI of the OB core system, which is syscore or OBI core, to speak to the base LLM. To have the vision model, the accessibility feature, the voice interface, and the robust interface. this will allow you to literally just develop features that can be evolve and adapt, which is thing we all do. We try to evolve and adapt our code. But this is a polyglot system. It allows you to talk to any language, which is Rust. So when you get something called OBI code.exe, you are using that to talk to Python for your voice interface, Node for your robotics interface, Python, accessibility, etc. for your accessibility interface, and this can be enabled and disabled on the fly by the user who wants to interact with that system. After being downloaded on the AI system they use it. Maybe it's a drone, maybe it's a AI system, maybe it's a car system. But this allows it to be downloaded and work virtually anywhere. Yep. So this is the input output. So let's go to the other document now. So this is called okay. So now I'm gonna talk about more about the filter flash indexing. Let me see. Okay, I won't give you this one yet. This one will be. I'll just sum up this one. So this is like the filter flash. So OBA works in something called the filter flash architecture. The filter flash architecture refers to how we know what we know, which is called epistemic reasoning. Epistemic meaning, do I know? How do I know? How do I know how am I sure? How do I know? How can I check? This is filtering is a cognitive model. Filtering refers to the sorting out of information and like processing. Flash refers to the concept of storing information in a cohesive, remembering it basically. So that's what flash remember. Like structured unboxing. It is just storing that data, but in a retrieval manner, back as like a disk structure to store it. Storing refers to the concept of storing that data that AI has got in a way that can be easily processed back again. Filter flash system. Whether it's a new insight or not, the AI must be able to cohesively remember it and load it up at any time. Flashing refers to the process of gaining new insights. Let me give you an example. Say you have a child, you have a child, you have a young child, the mission gives. So this is how it works. So one second. One second. Let me just one second. So how the AI system works is something called epistemic reasoning. It's meant to know how do I know what I know. So this works with something called my DAG, acyclic DAG, or directed acyclic graph, and using the filter flash. Filtering means understanding what you're understanding, and then flashing it means storing it in memory, and then understanding it. So let me give you an analogy. So say you have like a child. Let's give you a child example. I have a girl. I don't have any daughter, but I don't have children. So we have like a filtering is mostly objective. So it can be objective or subjective, but say you have like a puzzle piece. A puzzle piece. 1 centimeter wide. And you have a whole rim. To place that on a grid, on a one part, you give up, but you can do it eventually. But filtering is like sorting. How do I sort? What do I put here to actually place it? How do I start organizing this puzzle on the floor? So it's a consciousness model. It's like a model of cognition, consciousness. How we are aware. When you start processing the filtering, you then do a flash. You then flash it. You have an eureka moment. Okay, this goes here. This will get it, and you get. Yes. Now you go back to school. You go to so you now start filtering again. Now I got this piece. Am I right? Now you get a clear picture of what you do. You can try to find the first corner piece. If you really try to go optimal and work from the corner outwards. That's the most everybody's strategy. The simplest strategy you can take. Find the first corner piece, and then get that room to organize, and then you can start flashing it. But you can do that. That's called a flashing. Or filtering or flashing. Filtering just means sorting. But if you take a flash, you take any piece, you just start running. You just find any random fleet, and you try to build your way up to a solution to the full image, whether it's a space rocket or something more. So it's a space rocket, and then you get a space, the sky slide, a view from space of the Earth and space and the planet, the planetary system. That's the puzzle you're making. Now that's what it is. It's consciously evolving and adapting it. That's why we like this model of AI system, because it can adapt to any system, meaning that it evolves with intent. Whether you are Because why we have consciousness in the first place. And consciousness is a static thing. It allows you to dynamically learn and evolve from your experiences and the world around you. And that's the filter flash articulation of fast feature cognitions. It's meant to consciousness is a state of being aware, objectively and subjectively. The thing about system when we work on bias systems, on bias AI systems, is that when we why in bias, because you can tailor for everyone. It's easy to tailor for without getting bottled down on the nuances. Like works for any demographic, basically, whether in China, Japan, and we have like one more thing, the DAG. So how they actually so you get the filter flash filter, or you get the output. Then the AI listens to you or talks to you. It learns more about you. Opening says you AI, which is really we have something a term called actor. The actor term is not an agent, so it is the integration to act on your behalf. To make a request or do something on your behalf. What is request? When you write an email, send it to my coworker, but be nice. You can act on your behalf to go and send an email or postpone something or do something in the real world on the internet, being on the bias. We're not building what ABA represents or the intelligent Bayesian infrastructure for AI. This represents a system that you can always adapt and evolve it. Like any other systems, it's not just monolithic, it's non-monolithic architecture. You can use a Python binder like Pi OBAI to Pi OBA to net to speak to network interfaces. Or Node or Rust or you have a receiver, it allows you to adapt. Now about the IaaS platform. The IaaS platform stands for infrastructure as a service, and that's where all the polyglot system lives. So if you go to IaaS .obnexus.computing.org, that's the website I'm going to use to ship deploy the system. ISS replaces the policy system that there's a paid user service to use all the certificates together. The ISS service is just infrastructure as a service. It's the infrastructure, the polyglot infrastructure you can pay for, such as Polyco, if you want to pay for services for your business. To achieve some kind of but it's a pay-as-you-go service you can use to purchase, use to automate your system. So the DAG resolution is important because when you filter in Flash, you have to filter and Flash. The DAG is meant to say using something called verb noun concept. Now, one more thing, the verb noun concept is very important to this because the simpler model concept is called a verb noun pair. It's not really a concept. It's just like a like a thing like think a speeding car. Speeding car is just a concept. Slowing car or braking car is the same concept. Braking car, speeding car, slowing car. These are two concepts that a verb is for speeding, and noun is verbs are speeding and braking, and the noun car of the object. Yep. Which is the in real life using structural unboxing because it's already in there. But if you want to use unstructured unboxing to generate new data, it's like you can build a flying car, and that's what you're going to be. You can say if the answer is how do I build a flying car? And you start to be more formal, and you talk to AI. This is how you may build a flying car, but you have to be careful, here because blah, blah, blah. And that uses unstructured unboxing to depict how that model will work in the real world. We're trying to get the AI to be creative and solve problems, actually be useful, and not swap people, but be a pessimistic actor to act, to do a task. Whether you set a calendar note, the LBA AI is called you. Opening says you. Yeah, it's you, but it's yourself. What you tell it is what you get. But it's meant to solve your problem, being a computer system. Yes, so the DAG is just a directed cyclic graph that lives among the two layers of fast car, speeding car, and braking car to resolve a concept. Now, when you get two concepts that two pairs, two or more pairs, two, three or more pairs, that's a verb noun concept pair. That concept of fast cars or speeding cars or braking cars can now generalize among vehicles. You can now say, can I change that car to fast bus, braking bus, speeding bus, braking bus, or speeding motorcycle. If you're speaking about motor vehicle or bicycles or things that move, things that have action associated with them. but to move in a serious sense. These are called taxonomy pairs, which is my concept of verb noun pairs. Verb noun concept pairs refers to the concept you use to rectify a situation through formal. It's a formal concept modeling system for AI to understand how the AI system should not should approach a problem, not just crash by pattern matching. What a concept can I use to explore what's happening here in real time, and that's what we're trying to explore. Uh, so consciousness is a state of being aware, and the AI can subjectively reason are able to address it with dimensional game theory, which is a key theory of dimensions to strategies in dimension, offense, defense, attack, that you depict yourself for that set problem, which you're tackling. It's a very flexible system. Now we got one more thing about, say you have a system, so you now have a dimension group theory to use. Say you have like a signal, a tuning system, an input system. This input is meant to tune a slider. So say you go, you know all those airplanes, you know. Say you're making an autonomous airplane, you have a system for looking at inputs weather, and you want the AI system to know how to fly this plane. Now you want the AI to learn, but you know when it's flying, when the AI system learns enough, it will then come back to the ground and whatever. But you know you don't want a plane involved. You want to be able to put autoplay. Let's say autoplay. It's when they put you know all the dashboard of the AI systems are like buttons and dials, which is a very complex system. We're trying to reduce that complexity to make sure the inputs of the AI system can be found on the plane. So when an system is flying on a plane, flying people to people, you want to make sure that autoplay is just a safe place to go. So when you put or when it's landing thing, the AI system flies that plane, lands the plane, but the problem that the mission gets through is the inputs orchestration. Like how the inputs become outputs. Because if you put something in autopilot, you don't want to give maybe you have a degree of reason to give AI some permission to do something until the goal is achieved. But what the mission grid system should have like say you have a dial that amplitude like a radio dial to tune signals. That's the thing. When you tune a signal, you're really changing many options. Say until you get that picture, it's not just like a switch. You switch to this because it's an analog wave you are changing. So that's what it says. The mission game theory is meant to be for variety. It's meant to capture the variety nuances of understanding to address that set problem. And that's what dimensional creator holds. It's like if I make a slider up and down, and it works in inputs. It's analog. It's like analog or digital. You can go levels like that, or it can be in modes basically, like a level, like a gear system, or you can be in a fluidity of states, depending on what you want to have. We want this one dimension give to it allows the AI system to control the plane, just by being in modes, with limited options. It reduces it reduces the input space, and reduce the AI to make less mistakes. When changing gears and gets to two pilots who sit in the cockpit slowly out of the way. Using a filter flash model because it learns from observation. And that's what the OBI AI system, it's a reflection of me, my condition, my thinking, that I put on paper to make sure that it's coherent. Now you can change the proof at github.com/obnexus/patents, which is github.com/obnexus patents. Just look at the patent disclaimer. Just come and steal the work, but it's 25 years patents. Yeah, but you guys can read the proof, and I never know, but I haven't really paid for it. Just look at the proofs. Just read the proofs and see whether it's coherent to you. They're all PDF documents, so you can go to github.com/obnexus patents and read the formal proofs. Yes. One more thing. When we have the AI systems, AI is here already. The ecosystem, you have to understand that one more thing. Let me give you an analogy. Say you have a small daughter, a little girl, not a daughter, maybe you know your daughter, maybe some daughter, and you want it to objectively understand what you're saying. How this actually works, you give it 5 colors. She said, and you're teaching her the colors of the rainbows. Richard of York gave battle in vain. But you don't tell her the colors, you want her to learn objectively. So you said, And you don't tell her. So she said you give her the color names, but you don't tell her which color you want. So you said, this is blue. B for blue. You know, and she just look at the colors of the names tags. You know, and that teaches the AI. Okay, yes, this is blue. It's in trial and improvement, trial and error to address that scenario. So when she just picks a long color, you then take that color out and let her try again. That's what you want to give the AI to understand what is the concept you're trying to explore. You know, not just showing a blend images. That's objective reasoning model using dimensional game theory. So you want the AI to be doing training. Training is very important. Using unsupervised training, unsupervised learning. So unsupervised learning refers to the concept of letting it try again and coming back later to see that result. Supervised learning is like saying so you give it this situation, do the test, and then supervised learning is like, you know, I'm gonna watch your inputs. I'm gonna change to see what output you give me. I'm gonna supervise you to get the right output. Yep. And then we got supervised learning, and then we got unsupervised learning, which is the concept of not supervising the AI to do something. You know, like, you know, you do more like test, but you don't supervise the AI in the transition. You simple because you're doing you let the AI do the test, come up with concepts, explore that problem using dimensional game theory, and then unsupervised to make sure it's doing that job. And then you go reinforcement layer, which is really generative AI systems that takes the input and go back to the input output. You know, in a cycle, you know, it reinforces itself what it knows based on the new data set. Do I understand what I understand? Do I not understand what I don't understand? You know, it's just to understand this thing clearly based on the QA matrix structure. So that's what I'm saying. So, you know, when the AI is in real world, we also deploy a 95.4 metric clamp system. You know, how this works is for the consciousness model. You know, for vacation. You know, this is like a test to regulate real world AI. You know, things that operate in the real world, not in your bedroom. But you know, things that drive trains, run places, you know, because you know it's meant to be safe. What we consider safe AI. Why 95.4%? 95.4% is useful here. It's meant to be a benchmark for everything. You know, 95% refers to the clamping radius. You know, for the consciousness model, it's supposed to be understanding the concept around it properly before it's deployed. You know, this is a positive magma using the QA matrix. True positive, false negative, false positive. You know, that's what the AI is meant to be doing. And then the 4% is like, you know, if I don't understand by four, by four, but four, you know, and I round down, and a big frustration. I round to 95%. So it's like if it's 95%, it's a clamp. It's a clamp between 95 and 100%. Of the current understanding while it's driving in the real world, why it's flying a plane in the real world, why it's why the air is on the autopilot. You know, that's what the 95% metric understands. Now, the subject reading model, which I didn't say before, for the metric questions, when you get a little girl to internalize the colors, so you give her, you can write something up down about that color. You know what she knows. This is, and she says you give her a note to get this is a color. This is meant to be this kind of color. You know, you give her hints too. You can give her hints, but until she subjectively understand that this is red, this is green, this is blue. You know, using dimensional game theory, which is like strategies to get someone to understand something in context. Now, the dimensional game theory is meant to address this kind of problems. It can address dimensional problems, or it's not just dimensional game theory. It uses to address problems in war, problems in AI system, health and social health system, organ failure, big systems basically. And that's what the ontological Bayesian infrastructure for AI represents. Okay, now, thank you for watching. Like, share, and watch these videos. You can go to github.com/OBAIAI when it's complete, but it's going to be written in Rust. But the proof is ready. You can check it out yourself. You can download the repository. But don't steal my work, okay? Thank you. Attribute me when you do. Thank you. Bye bye.